So let's just put it out there right away. The conversation around AI lately has become, frankly, a bit exhausting.
Oh, you mean the whole Terminator versus Utopia debate?
Right, exactly that. It is always so binary.
Look,
Either AI is going to solve mortality and let us live forever on a cloud, or,
that's going to turn us all into paper clips.
yeah, it's great for movie scripts, but for actually understanding where the tech is going, it is honestly pretty useless.
It distracts from the actual engineering, that is for sure. And that is exactly why I was really looking forward to unpacking this specific source today.
Same here. For those of you listening, we are taking a deep dive into a transcript from Professor Peter. It's titled The Future of AI, What Comes Next? And honestly, it feels like the antidote to that entire hype cycle.
It really does. You
Yeah.
feel like the adults have finally entered the room. Professor Peter isn't talking about sentient robots or magic. He frames AI fundamentally as a tool.
A powerful tool, sure, but one that is defined entirely by, and this is the key phrase from the source, how wisely we design and use it.
Right. That concept of wise design is the anchor for this whole discussion. We're moving out of the Wild West phase of AI. Where developers just threw things at the wall to see what stuck.
Yeah, the move fast and break things era.
Exactly. We are entering a maturation phase now. And the source outlines 4 specific directions for this. Explainable AI, edge AI, quantum AI, and sustainable AI.
And what I really like about this roadmap is that it addresses the actual friction points we are all feeling right now. We aren't just talking about more power. We're talking about trust, access, and cost. So let's start with the trust part.
Yes, let's do it.
Explainable AI, or XAI.
This is arguably the biggest hurdle for institutional adoption right now. To understand XAI, we kind of have to talk about the black box problem first.
Right, the black box.
And I know you know this, but just for the sake of clarity for everyone listening, most deep learning models today are essentially opaque.
It is the classic computer says no scenario.
Exactly.
You feed data in, say a loan application or a medical scan. It runs through a neural network with a billion parameters and it spits out an answer. But if you ask the engineer why it gave that answer, they literally cannot tell you.
Right. The machine has found a pattern, but it hasn't generated a rationale. Now, if you are using AI to generate, I don't know, a funny image of a cat,
Nobody cares how it got there.
right, nobody cares. But Professor Peter points out that we are deploying these systems in high-stakes environments now. Healthcare, banking, law, governance.
Education, too. But this is where I always like to play devil's advocate.
Go for it.
If an AI looks at an MRI and detects a tumor that 3 human doctors missed, and it saves a patient's life, do we really care how it knew? I mean, isn't the result the only thing that actually matters?
In a pure utilitarian sense, maybe. But in a systemic sense, absolutely not. You cannot build a legal or medical standard on magic.
Fair point.
Let's look at the banking example from the source. If an AI denies your mortgage, legally and ethically, you are owed an explanation.
Yeah, you can't just accept a no.
If the bank just says, the algorithm didn't like your vibe, that is a massive lawsuit waiting to happen.
Right, so XAI is essentially about forcing the system to show its work, just like in grade school math.
It is about accountability. XAI systems are specifically designed to output the decision and the evidence trail simultaneously.
So it would say something like, I denied this loan because the debt-to-income ratio in this specific sector was too high.
Exactly. Or in your healthcare example, I am recommending this surgery because these specific biomarkers suggest a 90% probability of success.
Which also seems like the only logical way to debug these things. We've all seen those headlines where an AI turns out to be incredibly biased.
Oh, absolutely.
Like those hiring algorithms that downgrade women's resumes. If you can't see the reasoning, you can't fix the bias.
That is the critical point right there. Fairness is impossible without transparency. If the box is black, you have to assume it is biased.
Wow, yeah.
XAI forces the box open so we can audit the logic. It changes the whole dynamic from trust the machine to verify the machine.
So we are essentially moving from a black box to a glass box.
I like that, a glass box. Yes.
Okay, so that covers the how of the thinking. But the next trend Professor Peter highlights is the where. And this is a shift that I think a lot of people overlook because it is very hardware focused. We're talking about edge AI.
This is a massive swing in the pendulum. For the last decade or so, the entire philosophy in tech has been send everything to the cloud.
Right. You talk to your smart speaker, it records your voice, sends it to a massive server farm in another state,
Processes it and sends the answer back.
which works great until it doesn't. We are hitting a wall there, aren't we? I mean, just purely on bandwidth alone. We are generating so much data now that we literally cannot upload it all.
We call it the data gravity problem.
Data gravity.
Yeah, the data is just too heavy to move.
Mm-hmm.
But it is also a huge latency problem. Professor Peter brings up the example of autonomous vehicles, which is perfect for this.
Because of the reaction time.
Right. If a self-driving car sees a child run into the street, it cannot afford the milliseconds it takes to send that video feed to a server, have it analyzed, and get a brake command back.
Yeah, you would hit the kid before the signal even got back.
Exactly. The decision has to happen right on the metal, right there in the car. That is Edge AI.
Moving the intelligence from the centralized server to the device itself.
To the phone in your hand or the car on the road.
But there is a trade-off here, surely. I mean, my smartphone has a great chip, but it's not a supercomputer. If we move away from the cloud, aren't we making the AI dumber?
That definitely used to be the case. But the hardware is really catching up now. We now have NPUs, neural processing units, built directly into phones and smart cameras.
So they have dedicated hardware just for the AI.
They do. They're specialized just for this one task. And while they aren't as powerful as a massive server farm, they offer 3 things the cloud cannot give you: speed, security, and connectivity.
The security angle is super interesting to me. I assume that is because my personal data doesn't have to leave my house?
Precisely. If you have a smart camera monitoring your home, Edge AI allows it to recognize, hey, this is a stranger, without ever streaming a video of your living room to the internet.
The processing happens locally.
Yes. From a privacy standpoint, that is a huge selling point.
And then there is the connectivity piece. Professor Peter mentions medical devices in remote areas. This feels like the most human-centric application out of all of this.
It is the democratization aspect of the technology. If your medical AI requires a high-speed 5G connection to the cloud, it is completely useless in a rural village with spotty Wi-Fi.
It becomes a privilege, not a tool.
Exactly. But if the AI lives entirely on the diagnostic wand itself, a doctor can screen for diseases in the middle of nowhere. It untethers the intelligence from the infrastructure.
It makes the tech rugged. It is not just for Silicon Valley anymore. It is for the field. Okay, so we have got transparent AI with XAI. We have local AI with Edge AI. Now we have to talk about the elephant in the room, or rather, the quantum mechanical ghost in the room.
Quantum AI.
Yeah. I feel like quantum is just one of those words marketing departments slap on things to make them sound cool and futuristic. But in this context, we are talking about a very specific, very real leap in computing power.
We absolutely are. And we have to be careful not to get bogged down in the physics here, but we do need to understand why this is fundamentally different. Classical computers, like the one recording this deep dive right now, think in straight lines.
They are serial processors.
Right. They check option A, then option B, then option C.
Like solving a maze by walking down every single corridor one by one until you finally find the exit.
That is a perfect analogy. Quantum computers, due to the sheer weirdness of quantum mechanics, can essentially explore all paths of the maze at the exact same time.
Which is mind-blowing.
It is. And when you combine that parallel processing power with AI algorithms, you get a tool that can solve complex optimization problems that would take a normal supercomputer 10,000 years to finish.
The source points to 3 specific fields that are going to be revolutionized here: medicine, science, and climate research. These aren't just random picks. They're all essentially complexity problems.
They're simulation problems. Take drug discovery, for example. To find a new cure, you have to simulate how a drug molecule interacts with a protein in the human body.
And there are millions of ways they could interact.
Billions. It involves physics, chemistry, and biology all happening at once. It is a chaotic mess of variables. Classical computers just choke on that kind of data. Quantum AI could theoretically model that interaction perfectly in seconds.
So instead of 10 years of clinical trials and testing in a lab, you do all the heavy lifting in a digital simulation.
That is the promise, yes. Or look at climate modeling. We're trying to predict the weather 10 years from now based on ocean currents, carbon levels, ice melt, and solar activity.
All interacting with each other constantly.
Right. It's just way too much data for binary systems to handle accurately. Quantum AI is the heavy artillery we actually need for those global scale calculations.
It sounds incredible, but I have to assume we aren't seeing this on our smartphones next year. Quantum computers are notoriously difficult to build, right? Don't they need to be kept at absolute zero, and they are super unstable?
Oh, absolutely. It is still very much an emerging field. We are deeply in the experimental phase. But the fusion of these two technologies, quantum hardware and AI software, is widely considered the endgame for high-performance computing.
In next industrial revolution.
Computationally speaking, yes.
But, and this is a very big But all this processing power, whether it is quantum or cloud, comes with a receipt. And that leads us to the fourth and final pillar in Professor Peter's roadmap: sustainable AI.
Yes. This is the reality check we desperately need right now. We have been so focused on what AI can do that we have almost completely ignored what it consumes.
I read somewhere that training a single large language model consumes the same amount of water and electricity as a small town. It is genuinely staggering.
It is. And as these models get bigger, and as we rush headlong toward quantum AI, that energy demand is scaling up, not down.
There is a genuine irony here, isn't there?
A painful one.
We just talked about using quantum AI to solve climate change. But if building and running that AI requires massive amounts of energy that worsens climate change, we're essentially just chasing our own tails.
It is the snake eating its own tail.
Exactly. So what does sustainable AI actually look like in practice? Is it just running server farms on solar power?
That is the infrastructure side, and yes, that definitely helps.
Yeah.
But Professor Peter is talking about sustainable innovation at the design level.
So how the software itself is built.
Right. It means writing code that is inherently efficient. It means concepts like tiny ML.
Tiny ML.
Yeah, making machine learning models smaller and leaner so they don't need a massive power-hungry data center to run in the first place.
So basically not using a sledgehammer to crack a nut.
Exactly. Do you really need a trillion parameter model running on a supercomputer just to tell you the weather forecast? Probably not. Sustainable AI is about right-sizing the tool for the job. It is about realizing that compute power is a finite resource with a real-world environmental cost.
Which brings us right back to that concept of wise design from the intro. It is not just about the AI being smart, it is about the design being smart. If we build a superintelligence that burns down the planet just to keep its servers running, we haven't really succeeded.
We have failed the test completely. And I think that is exactly why these four pillars sit together so well. They balance each other out.
Let's actually look at that balance for a second to recap for everyone listening. We have XAI, which provides the trust and transparency.
We have Edge AI, which provides the access and privacy.
We have Quantum AI, which provides the raw power for the impossible problems.
And Sustainable AI, which ensures longevity and responsibility.
It is a complete system. If you take one away, the whole thing kind of falls apart.
It really does.
If it is powerful but not sustainable, it crashes our grid. If it is powerful but not explainable, we can't trust the decisions it makes.
And that leads us perfectly to the conclusion of the source material. Professor Peter wraps this whole roadmap up with a sentiment that I think is really profound. He says, the future of AI is not just about intelligent machines, it is about responsible human decisions.
I love that. I really do, because it strips away the agency of the machine. The machine isn't doing anything to us. We are doing it to ourselves through the machine.
We are the architects. The AI is just a mirror, really. It reflects our priorities. If we prioritize speed over safety, we get dangerous AI. If we prioritize profit over sustainability, we get wasteful AI.
The roadmap isn't actually for the code, it is for the coders.
That is exactly it. It puts the burden back on the humans.
Which is both incredibly empowering and slightly terrifying, given our track record as a species.
It is the ultimate challenge for us right now.
So here is the thought we want to leave you with today. If the future of AI relies entirely on responsible human decisions, as Professor Peter argues, how do we ensure that the humans in charge remain as accountable as the machines they are building?
That is the real question.
Right, because we talked about XAI forcing the machine to show its work, to be debugged. We have strict protocols for debugging code, so it isn't biased. But we don't have XAI for the boardroom.
Oh, that is a great point. We don't have a glass box for human logic.
Exactly. Maybe the next leap isn't just about stricter protocols for the software, but stricter protocols for debugging our own human decision-making processes. If we're the ones steering the ship, we need to make sure our own compass isn't broken.
Now there's a deep dive for another day.
Truly. Thanks for listening and exploring this with us, everyone. We hope this gave you a clearer picture of where the tech is actually heading past all the sci-fi noise.
See y'all next time.